Can you guys hear me?
Yeah.
Okay. Okay, I think we're gonna get started. My name is Melody. I'm gonna be the moderator for tonight. And then we're going to start out with some introduction with the panelist. And we're going to go into some questions, general questions about machine learning, and then go into some questions about interview, getting a data science interview, what to expect. And after that, we'll go towards some more general questions again. And after that, we'll open it for questions from you guys. So yeah, can we start with the introduction? If anyone want to go first. Okay, we're doing it alphabetical order. Okay, go ahead.
Oh yeah, sure. I could go first. Hi, my name is Siddharth Surana. I'm a third-year computer science student, and I only recently got into data science. I've worked at two data science-related co-ops, one at CIVC Data Studio, one at Darwin AI. Last one focusing on deep learning engineering. And yeah, excited to be here.
Hi, I'll go second. I'm Hillary. I actually graduated from biomedical engineering at University of Waterloo, but now I'm doing my master's at U of T in computer science, and my research is specifically in natural language processing in healthcare. My last internship was in Silicon Valley at Ultimate Software, where I did NLP projects relating to sentiment analysis, and I use state-of-the-art word embeddings such as BERT and whatnot. So yeah.
I guess I could go next. So, hey guys, I'm Navya. I'm third year computer science and finance at Waterloo right now. I probably got into data science in my first year on campus, and I've mainly worked at the intersection of computer science and finance, and that's included like risk modeling at Genworth and like trading models at the Bank of Montreal Capital Markets. And currently, I'm actually working in a data science and operations analytics role at Loblaw. So excited to be here.
Okay, I guess I'll go next. Hi, I'm Nick. I'm a computer science and statistics major here at University of Waterloo. In terms of data science stuff, I've kind of done a broad range from like data science to software engineering to research. And so I've like done data science and fraud detection for insurance. In terms of software engineering, I've been working on some performance optimization stuff recently. In the past, I've done some open source work in like deep learning. And I've also done like research in the self-driving space. And so that's kind of the range of my experience.
Sabrina, do you want to go next? Okay.
Is she frozen? She looks frozen.
Yeah, I think there's some connection issues. How about I follow up on the intro, and then maybe when she comes back, we can do her introduction. So I guess my next question is, what drawn you into the field of machine learning?
Do we want to go in the same order?
Yeah, sure.
Okay, cool. So I think I think I first got interested in machine learning when I was in high school. Just like doing some general readings and like seeing how the field is developing and implications. So that's when I first started that's when I first started reading into it. And I took that one course that everyone has probably taken, that Andrew Ning introduction to machine learning. That's where I like first kind of got into it. But I didn't really know how to enter the field until I got to university. I went to a few events on campus, further research, talked to a few profs and mentors, and that's how I got into it after my second year.
So for me, I actually got into machine learning pretty late, I'd say. But I was always a huge fan of math. Like in high school, I wanted to be a math professor. And I had actually done a lot of software engineering co-ops, and then I realized I found it sort of boring in my opinion, and because I prefer algorithms. And So then I first took pattern recognition. It's a systems design engineering course taught by Alex Wong at Waterloo. And it was, I sort of fell in love because it was mathematics, but it was applied. Like you could use your math and make things that can have like a positive impact on the world. And so from then on, I started to pursue like undergrad research assistantships. And then from then on, I got my first data science position at Bell Canada. And then after that, I worked at Ultimate Software and I did state-of-the-art NLP research. And then after that, I was like, okay, I want to pursue this even further. And so now I'm doing my master's in with Professor Frank Redzik at U of T, and I'm affiliated with Vector Institute, which is, for those who don't know, like Jeffrey Hinton, he founded Vector Institute, and he's the godfather of deep learning. So yeah, very excited.
I guess my interest in machine learning actually started on campus with the Problem Lab. They actually host an event which is the $1 billion problems, and they talk about some of the largest issues that do not have formal solutions to them. How do you actually tackle, say, urban planning in ways that, say, optimize energy consumption? Or how do you plan your transportation routes? I- Is there like a heuristic that would, say, minimize travel times? Or like, is there a metric that you use to plan neighborhoods? And these kind of open-ended optimization problems is what actually really got me interested into machine learning, because it's not a field that's simply restricted to something like a classification or a regression. It comes down to the kind of problems that you want to tackle and the wide breadth of just techniques that you have to address them. And so it started from the $1 billion problem pitch, and I got into a lot of these optimization courses online. Spent some time actually trying to like read up on the maths behind deep learning, and that's when I got into. I really enjoyed reinforcement learning, which is by far some of like the most interesting stuff that I've enjoyed working on. An example of that actually being DeepMind in 2013. They released something called the DeepQ networks, DQN, that actually learned how to play Atari games simply with like a 256 by 256 grid of your game mode. So how like the amount of nuance that has to go into something like that, where you need object detection and you need to learn optimal actions. And that was something that really fascinated me. So from there, I'm currently just doing an undergraduate research assistantship on campus to explore some of these questions. And yeah, that is what it has been so far.
I think for me, it's like very similar to what Hillary said in that I guess before university, I've kind of tried things in web development and stuff like that. It wasn't really for me. And then kind of once I got to university, I learned about this thing called like machine learning and data science. And it was really cool how much like math was involved, how much algorithmic thinking was involved, as well as like the practical side. So there's a really nice union of academic like study as well as like practical industry application. That was really fascinating. And so that's what kind of got me into it. And through trying the various roles, there's just so much breadth in what you can do. So kind of no matter what you're good at, there's kind of a place for you, but you're always working on these extremely interesting problems. And there's always a lot of demand for it as well. So I think that's what kind of got me into it.
Okay, makes sense. I think Sabrina is back. Her video is not working, but her audio is. So do you want to give an intro?
Yeah, sure. Yeah, apologize in advance. Like it went wrong in the worst time possible. Like the moment that I wanted to say something, and then it keeps reconnecting. But yeah, I turned the video on and it works well now. So yeah, I guess I can do a little bit of intro and like it might kind of answer the first question a little bit as well. It's similar to Hillary and Nicholas that I tried a bunch of different roles. At the beginning, I was doing my first internship in data engineering. And then the second one, I joined a very small startup working on full stack and a little bit of infrastructure. After that, I went to Apple to do DevOps. And then after that, I joined Nextdoor to do machine learning engineer. And there I mainly was focusing on NLP and then doing a lot of things like studying social media, all the things that you see like in whatever. So yeah, that's a little bit about me. And after trying different roles, I found myself like particularly very interested in the data field. So yeah.
I see. And I know you guys, I think a few of you guys are interested in natural language processing and some optimization. So I just want to ask for those who know what you like within machine learning, like how did you choose that field, that subfield to focus on?
So personally, how I chose it was actually through, well, I'm going to explain it in machine learning terms. So like exploration versus exploitation. So there's a lot of exploration in the beginning, like narrowing it down to machine learning was already like pretty difficult because there's a lot of things that you could do like in terms of engineering and tech. And then I tried actually computer vision and some NLP and some quant. And also like data science in general, like data analysis. And I would highly recommend taking like undergrad research assistantships just to figure out what you like. Do research with a prof that you find really like their research very interesting. And also do side projects. Like for me, I did a lot of self-learning because biomedical engineering is totally not related to machine learning. So yeah, I recommend Medium articles actually. Like I remember doing a lot of like tutorials using Medium articles. And use incognito mode when you get blocked. And yeah, like YouTube videos of like tutorials. Nowadays, we're really lucky to be living in like a generation where knowledge is super easily accessible and you don't have to pay a lot of money to learn. So yeah, and then after just exploring all those types of machine learning, I realized that I found NLP really interesting, especially because I feel like computer vision is very well developed, but natural language processing, it's more subjective. And so it's like difficult to create better like NLP systems. When you think of today's like Alexa, Amazon, Alexa, and like the chatbots, you can see that they're really lacking in terms of like memory and personality and etc. Yeah.
I could go next. So I would definitely agree with Hillary that the best way to kind of discover what you like is going into it and actually trying each section of data science and seeing what you actually find an interest in. So that's kind of what I did, like through co-ops and just side projects. In like basically what Hillary said, but in addition, I would also say like reading research papers has also helped me a lot, especially if you're looking to get into more of like a research role or you want to do like a URA. Sometimes it benefits you to know what's happening in the field right now. So that's also something I would recommend. But yeah, basically just exploring the field as much as you can. Not waiting to take the courses in school, because by the time you take those courses in school, your co-ops are usually already done, or most of them are done. So to get like a competitive edge, you really want to be researching this stuff on your own early on, doing projects and trying to get co-ops in the field you're interested in early on.
I think to add on to that, when I tried to like explore the field at first, it always starts with like a lot of those introductory problems that try to get you acclimatized to the field, your Titanic data set, your Iris data set, something like that. But from there, it was always about finding either information or topics that I was really interested in and trying to say work on models in that space, or trying to find new subtopics within machine learning and trying to learn them. And so, for example, my best recommendation would probably be Kaggle, because for any topic that you're really interested in, you can either find, say, a data set that someone's uploaded on that topic. For example, I actually wanted to explore the application of NLP techniques to economic news, in the sense that can we say, take news headlines from like major newspapers and tag them for like economic relevancy, which is like some of these metrics that the SEC uses. And so there were like data sets on this that were available on Kaggle, and you can use that as a starting point. Or something that I really enjoy, which is like the intersection between optimization and computer vision. There are really interesting open challenges on Kaggle right now. There's something called the Game of Life, which is like a single player automaton that is like a non-deterministic game. And so the challenge is really, can you use computer vision to try to reverse the states of this game? And so a lot of these are really hard problems. Like no one gets them right the first time around. Like no one gets a perfect accuracy. It's that like I can attest to how much I have learned just by, trying different approaches. Maybe if you get stuck somewhere, you pull up a research paper that say used a specific technique. For example, one of the techniques that's been really used in that Kaggle challenge were like conditional GANs, which was something that was first experimented with in a 2017 paper where they tried to use it on like Google Map images. So like you come across a research paper now, actually reading through that paper to actually find the different techniques that might best apply to what you're working on. And in that sense, that iterative process works the best. And the other thing that was really instrumental in how I think I went about it was, is the first focus on trying to understand the nitty-gritties of all the mathematics behind these models? Or is it trying to get your hands dirty with implementation and infrastructure first? So what worked best for me when I started was, first I tried to get my hands dirty with just techniques in general, like using scikit-learn, say using Keras, and just trying to get models up and running on simpler data sets. And once I was able to get that part done, then I was able to delve into the math and probably understand it much better than if it was thrown right at me. But at any step beyond that, getting through the math and then trying to build models, or just the practice of trying to read research papers, is something that's been really, really helpful.
Yeah, for me, I don't even know if I can answer the question of like what I'm exactly interested in. I guess I still don't know. I know that I'm interested in like applied research and research for, I guess, career-wise, but topic-wise, I have no idea. But yeah, my strategy's really been try as many different things as I can through my co-ops and URAs. So just to give you a sense of some of the stuff I've tried, I've done like insurance, like modeling insurance fraud in my first co-op. I did a URA in like program synthesis and identifying bugs in code. I did like deep learning open source work on a library called KFAC, which is like a neural network optimization algorithm. I did a URA in like kind of probabilistic modeling. I've done an internship in like self-driving research, and I'm currently doing an internship in like optimizing performance of machine learning inference. And yeah, I'm looking to try something new for my next one as well. Oh, and I've also done a URA in like differential privacy. Like I've tried a lot of things. All of them are really interesting in their own ways, and I have no idea exactly what I'm interested in, but I think my strategy going forward is still going to be exploration and then kind of see where it takes me.
Yeah, 1,000% agree. So I also don't have like a specific area that I know that I'm gonna dive into super niche about it. And also I feel like college is a great time to just explore different fields. To even within the data science field, there's so many different like topics, ideas. Yeah, because so I feel like one thing to get like really able to get started, there are some good ways, like definitely there are a lot of like tutorials online and everything. But I think the breaking point for me to like really understanding things is actually through a co-op, that when you have a real life example and like some mentor that's like really guiding you, it really helps you accelerate the understanding of like what the problem is and how to use all the tools and how to put everything together. So in terms of like trying, definitely it's really, really helpful to also, it would also help you gain understanding of like other, like just like extrapolate your understanding from one problem to the other one, because you can start to see the similarity between them. So I also did like 2 URAs on like different topics of like machine learning. One is about like adversarial, and then the other one is about like, well, it's also NLP, but it's mainly focusing on different areas. So the URA was mainly looking at how to generate tags. And then my co-op was mainly focusing on like how to build up a better embeddings for the tags. And yeah, and I've been really enjoying like all of like just the exploration, so that like my goal is pretty much like after graduation, I wanted to know that which area that I'm like more interested in. And I feel like that's really helpful when you're in undergrad.
Yeah, I guess that's fair. Oh,
I just want to echo something that Sabrina said. Yeah, I totally agree about what you said about like having a co-op to try something, because I feel like there are things that I've done personal projects on which I either really enjoyed or didn't enjoy, and then in the context of a co-op, it's like very different. So one concrete example is like during my first co-op, I really enjoyed like, you know, talking to people who weren't technical and then convincing them of our models and like kind of pitching it and selling it. That was like a lot of fun. And on the flip side, like I enjoy doing performance optimization stuff for my own projects. And then as soon as I did it in a co-op, I'm doing it in a co-op and it's like, oh, okay, maybe this is not so much my thing. And so I know like co-ops are limited, but like your experience can be different in the workplace versus your own projects as well.
I see. I guess my next question is following up on how you guys said doing a 12 in data science is super helpful. It's about if you're a first or second year student and in STEM with no data science 12 experience, where should you start?
I guess, oh yeah,
Go
you
ahead.
can
No,
go
it's
ahead.
fine. Go ahead. It's fine.
Yeah, I guess I wouldn't give like a just like a golden guide of like just follow these steps. You're gonna able to find a data job. I guess part of it was actually luck in a sense that so at one point of my searching for co-ops, I was just like looking at different jobs, and then there are a lot of companies out there actually do the team matching after your internship, like after your interviews. So like after you're being able to like get into a company, and then you can express your strong feeling in like a specific area, so that you can try to get into teams through that way if you don't have too many experience in advance. But of course, just like if you still like if that part is still not possible, like definitely doing side projects, even though like in the team matching, if you have these points, like it will help you to get into the teams that you want as well. But in terms of like applying to specific job that's like focusing on machine learning, I think maybe other people would have better ideas on how to do that.
Yeah, I guess. Oh, sorry, go ahead.
Okay. So I think there were three things that really helped me get through, say, first year and second year. And that was one was trying to get familiar and like just confident with a lot of the infrastructure and the frameworks that data science usually requires. And that includes everything from, say, your data wrangling frameworks, your PySpark, your Pandas, or like, say, numeric computation, your NumPy or SciPy, or say machine learning libraries themselves, because one of the best ways to just gain a lot of that knowledge on your own is side projects. So just pick up a new library, say go through documentation. For example, a recently released one was something called scikit-learn extra, which covers like a lot of these unsupervised techniques that are not covered in like the main scikit-learn release. So just going through documentation, say finding like different implementations of a lot of these theoretical models, seeing what are the best scenarios that they can apply to. Say there is some kind of data that it's properly suited to, pulling up a Kaggle data set, say working with that model, understanding, say, edge cases, things that might like situations where the model may apply, may not apply. So it's just that iterative process that's really helpful. And in that sense, there are a lot of these MOOCs available online that just help you get, with the theoretical underpinnings of this. Say an introduction to deep learning that introduces you the concept of like artificial neural networks, or an introduction to computer vision, and those are the first steps to, say, building out a side project in that field. And at the end of it, you do not necessarily need a full-fledged data science role to break into the data science field, in the sense that a lot of roles are often at the intersection of software engineering and data science, stuff that say requires full stack expertise with some amount of data science. So if you have very strong software engineering aptitude, you can always look for those kind of roles, get that fairly limited but industry experience in data science, and then slowly carve to the other side through that direction. But yeah, I think that's more or less it from my end.
I have a super like biased and prescriptive answer. So yeah, this is like a question that is asked a lot in data science club, like throughout like every term we have data science club. This is like the first question people ask. And so I've taken a lot of time to like reflect on what works and talk to other people. And so this is like kind of my prescriptive guide. It may not work for you, but like kind of curated. So I guess the first thing I would suggest for someone who's completely new to data science and doesn't understand anything about it would be to check out, like on Data Science Club's YouTube channel, we have an introduction to different roles in data science. And I think that's like a good place to start. The next place would be like Kaggle. I think Navya mentioned Kaggle. They also have these really, really high quality courses. And so in all topics of data science, my suggestions would be to start with Python, Pandas, DataViz, and Intro to ML. Like those four are like really basic starters. They're relatively short. I think they like are a really good way to start. After those, like they suggest you check out some Kaggle competitions like as a part of those mini courses. And that's like an excellent way to get your hands dirty with data science. And so you can do some of those projects through there. They lead you to like some introductory data sets, but of course, after you kind of practice on those, you can branch out and find anything you find interesting. After that, there's a course called fast.ai, and I can link all this stuff later. But I think, in my opinion, that's like the best beginner deep learning course out there. I've like watched several, and I think this is like a really good one because it gets your hands dirty right away. And it also has some really good like tools and tips for building like projects. Like Jeremy Howard, who teaches the course, he goes over like, okay, so we learned how to do this. Can we actually deploy this in a web app? And he spends like 20 minutes of one of the lectures saying like, okay, so you can actually deploy this in a web app. So he's like super pragmatic, but he also covers like the theory aspect. So I think, in my opinion, it's an excellent course. The only downside of that course is the library used in that course is like not so widely used in industry. But I think when you're learning, it's an excellent tool. And I think after those couple of things, you kind of have all the tools you need to like branch out and do anything you find interesting. And so, yeah, that's like my 3-step guide to becoming successful in data science. Definitely not the path that I took, but kind of reflecting, I feel like that's what I wish if I started now, that's what I would do.
To add on to that, I'd like to say that I know in our Waterloo culture, we have this thing called Cali or bust. But when you're in your first or second year, I highly recommend getting the job for the learning experience, not necessarily for the money or the clout or whatever, because in your first or second internship, it's so much better to get experience in something that you actually want to pursue. Like, for example, I had like a biomedical engineering internship, but it has nothing to do with what I'm doing now. And even though it was at like one of the best transcatheter heart valves companies in the world, it just, it doesn't benefit me at all in terms of like learning experience. And I don't even have it on my resume. So I'd recommend like doing internships that are relevant to what you actually want to do. And also to not be intimidated by, I know like machine learning can be very intimidating for those who like aren't in it, but like just go for it and you'll realize that it's not as hard as people make it out to be, and it's not sorcery. And also I believe that interviewers, especially hiring interns, they hire for potential, not necessarily how much experience you have, but rather how passionate you are about learning. Maybe they see that you did a lot of side projects, or that, you know, for me, it was like I'd studied biomedical engineering, but I would, after class, I would study a lot of machine learning in my free time. And that shows like, oh, this candidate is very passionate about learning about machine learning and has the ability to quickly pick up new concepts. And I think that's a lot more important than experience. Yeah.
So I think you guys talked about like how to advance in more senior co-ops. I was wondering if this is your first internship, you've been applying for a bunch of data science jobs and you didn't get enough interviews or get any interviews. What kind of advice would you give?
Be free labor. So undergrad research assistantship. Yeah, I would. And then after you do undergrad research assistantship, you can put on your resume, and then it'll probably increase your chances for next time. And also, if you are not getting interviews, there's something wrong with your resume. That's the like the rule, right? So if you don't pass interviews, there's something wrong with your interviewing skills or your elite code. If you don't get any interviews, there's something wrong with your resume. You might have to exaggerate a little, put in all those keywords, Python, pandas, TensorFlow, whatever, but you should not exaggerate to the point where you're lying. But yeah, get your resume critiqued by someone who is in data science. That's what I would recommend, yeah.
Yeah.
I guess I'll go for it.
Okay, cool. Talk. Yeah, it's always us two on top of each other. Yeah, I definitely agree with what Hillary said. Like the URAs are they're so slept on. Like no one does them, but they're such a great way to gain experience and also like pad your resume as well. So +1 for that. And I think project is like so key. And it's like I think a lot of people make the mistake of doing a lot of projects or doing projects very shallowly, and that's not going to help you. That might help you maybe might get you help you get the interview, but as soon as you get the interview, it's going to be very tough to talk about that project in depth. My recommendation would be to do 1 or 2 projects for a long period of time. Like, it doesn't have to be hours on hours, but I'm just saying, like, invest a lot of thought and invest a lot of time. And so during the interviews, you can kind of talk about these challenges. And I've noticed that a lot of data science interviews, they always kind of ask you about why you made certain decisions, why you made certain assumptions, what alternatives you tried. And those are like the most important things you can talk about. And so you need to spend time in order to be able to talk about alternatives at all. So yeah, instead of like, shotgunning a bunch of different mini projects where you just fit a neural network and then call it a day, like do one that takes time. It'll definitely benefit you. In the case where you're not getting any interviews, well, you got to start a project, right? Like do 1 or 2, even if they're very shallow, very small projects. Like you got to do something to show that you have some interest in the field and some skills in the field. And Kaggle's like probably my number 1 suggestion for where to start.
I think one of my suggestions would be pick up a specialization. So a lot of these Coursera courses, for example, there is one on reinforcement learning by the University of Alberta, which is splendid, to say the least. And so what a lot of these specializations allow you to do is they cover a lot of those, like what Nicholas mentioned, a lot of those decisions that go into building some systems, what kind of considerations you need to make, and they often involve capstone projects where you're actually working on implementing some of this. So in that way, if say starting from scratch is often pretty vague, like where do you proceed? And so specializations may be a very good starting point for that. Apart from that, yes, you are a 100%, it's amazing experience. And there are also these open internships. For example, Major League Hacking, they had a fellowship program this summer, I believe, which was essentially, can you contribute to open source that is on some of the major libraries that are in production. So maybe you're really interested in data wrangling and say optimization problems. Can you say you might want to say join similar fellowships, work on some of the best open source projects that are something like Dask or something like PySpark or like MLlib, and essentially show that you have a lot of that knowledge to work with those frameworks and contribute to those frameworks. But yes, above open source contributions like URA and Kaggle is the best recommendation there is.
I could go. I'm not sure if it's already been said because my internet died. Sorry about that. But what I was gonna say is basically, like I know we talked about working on like side projects, specializing in the field a little bit. Something else that I guess this is more specific to non-engineering students or people who are allowed to switch their sequence. I didn't personally do this, but I've heard of people who, if they weren't getting interviews in their first co-op term, or looking for their first co-op job, what they would do is they take like a term off or do a study term to push their co-ops a little bit. And sometimes that really does help because like I know a lot of people come into university with varying levels of experience. Some people have already worked on a few side projects. Some people like have literally never like never really written any software. So coming in, sometimes it's a little difficult for your first co-op, but if you have a little bit of school experience and time to work on these projects, sometimes that could help if you just give it enough time.
Yeah, definitely agree. So like if like it's at a point that when you're really trying to get a job, and yeah, so in terms of long term, it really helps to do like those side projects and like really dive into things, and like there's basically I can't really think of downsides of doing a URA at all. So like highly recommend that as well. So in terms of like short term, like you're at the point that you're just applying for co-ops, and at that point, the most helpful thing is probably really editing your resume. So there's like different people with like similar experience, their resume could experience different results. So some places that you can get your resume critique is that Data Science Club does resume critique. So like getting feedback from people that have like gotten jobs, or like from people that experience in like how to like acted their resume in a certain way, that to emphasize things, like whether you want to highlight things, how are you gonna like put in different sessions in your resume. I feel like in short term, that's gonna be the most, well, in terms of like efficient of like how much work you put in and how much result you're gonna get back, that's gonna help a lot when you're really trying to find job within that a few weeks.
Okay, so just say that you got your first data science interview, and how would you compare the data science interviews with software interviews? And how do you approach the interview questions that's very theoretical, like very scenario based and open ended, and can mean a lot of different things? So, what's the best way to approach those questions?
I guess I could go on this. So a lot of data science interviews, at least from my experience, have been a combination of three things. One of them being a lot of your traditional software engineering questions, say something like a lead code, something like these questions where they're like, what's the asymptotic runtime? How would you go about this, etc., etc. The other aspect is some of your statistical concepts, and at least the statistics questions that I've had have been mostly second year statistics, something like say what a stat 231 or a stat 230 would cover. Say like sampling, analyzing distributions, maybe like two sample testings, stuff like that on say a scenario that they give you. And the third would be more machine learning based questions, which would be like, given this is a setup, how exactly would you go about with say feature engineering, or what is the best approach for feature selection under say certain constraints that you have. And some of the most open-ended questions that there are like, oh, how would you go about designing a system for xyz, or I think this was a question at a previous data science club event. I can't remember exactly, but it was like, suppose the project was to build a bridge between like a new bridge between MC and DC. How would you go about it? Like, this one seems to have nothing to do with machine learning to begin with, but the way that I would actually recommend approaching it is just trying to make a parallel between the way that, say, a machine learning lifecycle would be and something that the question requires. For example, the first step you need is defining your input data sources. What kind of information do you have available? Because in a lot of situations, some of the data that you might need might not actually be available. Can you find proxies? Is there a certain way that you want your data to be structured? Number two, metrics. That you can't minimize losses if you don't know what your loss is there, say, a certain metric that is best suited for the problem? Is there someone who should define the metric? Is the metric supposed to say change over time or change with relation to the data, so on and so forth? Defining how exactly is that optimization happening, like, is there some kind of update that you're making? For example, when you're making the bridge, I don't know, say you have access to footfall data and you have access to where different people have classes at what time. Is there some kind of transformation that you're making to get specific insights? Maybe what is the shortest time between a class in say MC and the next class in DC for a particular student. So what is like the average or like say a median travel time available, and building a bridge where would minimize that travel time. So just say transformations on your data. And the last step is actual deployment and edge cases. For example, suppose there is one student that has decided to take 15 courses and he's queuing all your input data because he has classes all over MCDC. How do you recognize, how do you handle edge cases? Or when you go into real time, how do you uh, is there like continuous input streams for your data coming in? For example, next year the university decides, you know what, let's move all the fourth floor MC classes to DC. How does your model react to like temporal changes? Is there like some kind of weighting that you assign your data? So just making parallels between some of these open-ended questions and a lot of the considerations that might go behind building a model is something that I've actually found really helpful. And it's something that I continuously try to learn from, say a particular side project you did, you had to handle very specific constraints. Can those constraints be generalized to something a normal project would involve? And so that would be probably a good way to approach it.
That's hilarious. You remembered my problem from the yeah, the MC bridge thing. That's like my favorite problem for like the data science mock interviews. But yeah, I think I agree with everything Navya said. One thing to add would be like another potential thing employers do is like project walkthroughs. And so they'll like, pick one of your projects or allow you to pick a project and just basically make you kind of walk through it. And kind of the structure I use to approach these is like I have like a 1-minute pitch of what the project's about. I'm ready to talk about 2 or 3 like technical challenges at depth. And then I like always focus on, depending on the role, like for example, for a research role, you really want to focus on the research aspect. Whereas if you're applying for like a product or data or business focused data science role, always kind of relate it back to your objective of like, you, for example, if you're doing some data analysis about like the Titanic, for example, like always related back to a business purpose, which is, oh, you want to save these people, right? That's kind of a business purpose. And so keep that in mind for certain roles. The one thing I do want to add is there's also like a resources doc that Data Science Club put together with like Tech Plus with like interview structure for data science stuff. And so maybe Melody, you can remind me after I'll like put all these links into one place for these people. And finally, like data science interviews, they like seem really intimidating, but I think interviewers really understand that first of all, you have no context, you're super nervous, you're super anxious, and you only have like your own narrow set of skills that you are bringing to the table and you're willing to learn more. And so they really keep that in mind when they're making their questions and asking you questions and helping you out through the problems. Like I feel like after every interview, I'm like, dang it, like that was not as smooth as it should have been. I was like stumbling a lot. They had to help me a lot, but like, interviewers understand like I came in with a certain amount of prior knowledge and they expected a certain amount of things. And so it always goes fine. So I guess that's my number one advice. Like, don't be too hard on yourself.
Yeah, definitely. I feel like a lot of the interviewers are not looking for a perfect answer, and also there's like not a perfect answer when it comes to like these open-ended questions. And I found it like tend to be more common for data interviews to ask about like open-ended questions about like projects and how to design things. So I feel like that's a totally different thing to like focus on preparing than like just the technical skills, like your coding skills with like your algorithm questions. So yeah, I feel like maybe prepare these two things like separately as like two kinds. And one is usually like your coding skills is probably like the more of the previous interviews, like try to see if you are a okay programmer, and then they'll proceed to ask you more like these in-depth like design question and like and to see how deep you understand the problem and how you're going to go approach it.
I could go next. So in my experience, the biggest difference between like software and data science interviews is that data science interviews are usually a lot more theoretical, and you talk more about your own side projects and like the technicalities of it, and like your thinking behind the side project rather than like anything like rather than just like doing like a coding challenge or something like that. So often what an interview will do, at least in my experience, is they'll ask you like why you made a certain decision, right? And then they'll like you'll explain it, and they'll ask you like further, like deeper into like, okay, so then why'd you choose A instead of B or something like that? Like they'll basically like probe you, not to get a certain answer, but more to understand how you think, and like how well you thought out your project. That's why, like going back to what Nicholas said, like having a really well thought out, well structured project rather than a bunch of surface level projects is a lot better. That'll definitely help you. But also like a lot of like data science interviews vary. So I have had a few where the beginning is mostly just a coding challenge, and then they'll ask you some like general like theory of data science. But it could definitely vary. So like going in with an open mind and kind of being able to uh, act depending on the challenge is pretty important. Like they don't expect you to know everything. They more expect you to be able to think on the spot and produce some like a good answer based on your prior knowledge.
I see. And I think my next question is.
Oh, sorry. Could I add something? Sorry, I just
Oh, sorry,
remembered.
go ahead.
Sorry. I guess like quant interviews are like included in data science as well. And this term I'm doing a lot of quant interviews, and to be honest, I'm getting destroyed on all of them. So I'm in no position to give you guys any advice on these interviews. But they're often like either like brain teasers or probability questions. And there's like, so if you guys are going for quant specifically, I would highly, highly recommend studying one of these quant books particularly, which go through like these brain teasers and these probability questions. Like I didn't do that, and I'm getting like absolutely like destroyed. And so would not recommend pretending they're like normal data science interviews, like prep specifically for quant. Okay, that's all I had to say.
Okay.
And small
Follow-up
add-on on
question.
that.
Oh, sorry.
December 6th to the 12th, I think, like it's essentially that week. Neuro IPS 2020 is happening, which is like the premier conference on like information systems in general. Uh, I'm actually trying my best to like take time off to attend. And the one thing that I really, really recommend and something that's been really helpful is just reading papers. And I cannot stress this enough, and just trying to be updated with the state of the field. Because I remember in one of my interviews, the interviewer just went on a tangent, say talking about how word embeddings have evolved in NLP, for example. She's starting from forget what it was called. I think it was word to vec, that then evolved into BERT, evolved into Roberta, that so on and so forth. And I think the new one was use, which was universal sentence encoders for like sentences as a whole. And so just being updated with the state of the field, so to speak, and what are say new advancements, what is something new that's always coming up. I remember I think it was a big thing about like the paper that was titled "Attention is All You Need," which talked about like attention mechanisms for NLP. So just reading up, maybe medium, maybe towards data science, may just be say random articles that you wouldn't cite in an academic paper, just anything that talks about the field.
I have a question for you. It's definitely helpful to like understand like we keep updated with like all these things. Would you have any recommendations of like where people could look up, like have a more systematic way to like keep up with like all these things and understand them?
Maybe I could take a stab. For me, like Twitter's. Oh, Navya, were you talking? Sorry, you were muted.
Oh no, go for it.
Sorry. Yeah, I know a lot of people will recommend like something like Archive Sanity or like various other sources or like Paper Digest. That's not my recommendation for someone generally interested in data science. I think that's for someone who's interested in research. If you're interested in data science generally, like I would make a Twitter. Like honestly, data science on Twitter is like popping. And if you follow the right people, your feed will like constantly have little tidbits of information. And like honestly, sometimes that's enough to kind of keep you on the cusp of things without investing too much time. And a lot of good resources like articles or they're like summarizing videos, they always bubble up to the surface. And I find that my feed is like a really good source of information for me without investing too much time. Of course, if you're into research, you should be like, following Archive Sanity or Paper Digest, something a bit more. But if you're interested in data science more generally, like something like Twitter is like a great thing to have.
You can also just Google like top machine learning papers or like top NLP papers. And normally there's like blog posts of summaries of like papers that have won awards and ones that are like more significant in the field, like have been cited more, for example. And then, yeah, that's actually how I keep up to date. You don't have to read the whole paper. You can just read like the summary. And then if you're interested, then you can like go into the details. Yeah.
Something that works really well for me is that just as Nicholas said, just follow a lot of these people who have the updates. Who That's like probably the best way you'd get to learn about the field. For example, that's probably how I just realized that like graph neural networks were a thing. And apart from that, it was just maybe people who are at the cusp of like say state of the art in a particular field. You can check out like their Google Scholar pages, see what kind of what are their cited papers and what they've been working on recently, and maybe you just want to go in and read one of those papers. So yeah, I think that works perfectly. I don't have a very structured way of going about it, but yeah.
Also, like I forgot to mention this, just to add on, it's good to have a community of people. So like, for example, this data science club is great. I found when I worked in Ultimate Software, talking with my data science team, actually, I felt like I learned a lot about like models that I didn't know about before, or like state of the art NLP models. And then now that I'm at Vector, which is like a literally an AI hub full of like hundreds of researchers with like professors, I feel like there's an infinite amount of knowledge that I can acquire from other people just by talking to them, asking them about their research, about about like if they can teach me something, or like resources for where I can find stuff. It's been really useful. And also like being in research, like doing my master's, I feel like talking to my professor and also talking to my lab mates, like I feel like I learn a lot. So yeah, community is really important. Don't be afraid to reach out for a Zoom call or something.
Yeah, definitely agree. I feel like within a community is the time that I like being able to learn the most, like to grab a little bit of new information from everyone, like either in an URA or like in an internship.
I just want to echo something Hillary said, like reaching out to people. Like when you're not at a company, it's very hard to kind of reach out to strangers. It's kind of intimidating. But when you're at a company and you can play the intern card, like, hey, I'm the intern who wants to learn. Like anyone will talk to you at the company, right? You know, you may be able to talk to like the CEO or something, or like a VP of AI or something, because you're an intern, and you can reach out and be like, hey, I'm an intern and I want to learn more. And everyone's like, oh, it's an intern. And then they'll like talk to you, and like everyone's very happy to share their knowledge with you. And so you should definitely take advantage of that opportunity while you're at companies. Like I try to make an effort to maybe talk to one person outside of my team per week if possible. That's like a very aspirational goal. It doesn't happen, but you know, it's worth it for sure. I learned a lot.
That's a very super useful tip. I guess my next question is, I know that some of you guys are doing masters or thinking about continuing education, and I know that within the data science field, education often matters a lot. Like even before it was only PhD, and now it's a lot of undergrad and masters are okay. So what do you think about the level of education required in data science right now? And given how fast the field has been changing, would you still recommend these people to continue in education?
Okay, can I talk about this? Because I'm a master's student. Okay, so basically, like, as a Waterloo grad in research, it feels a bit bitter because most of my friends are in Cali making like 6 figures and like living the life, right? But then you're reminded that like you want to, like, you're doing this not for money, like you're doing this because you love what you do, right? I mean, at least that's my mentality. I'd say like if you want to do machine learning research, you need higher education. Like you probably need a master's for sure. I mean there are exceptions. Like you could probably work at a startup and not need as much education. But if you want to work at like Facebook and like Google Brain and stuff like that, like I would highly recommend getting a master's and even potentially like a PhD. And if not, then you should at least have some like publications to show that you can do research. However, if you're doing like there nowadays, there's a lot of like data science and machine learning engineering roles, which is like ML SWE, which is like you do software engineering as well as machine learning, and you just implement already established like state-of-the-art machine learning models. Then you probably only need an undergrad, but I would say you get like plus points for having like a master's and potentially like a higher salary. Yeah, and also doing a master's, if you do a research master's, you could also get like research papers, which look great on your resume, especially, yeah. So that's my recommendation.
I could go next. So I would definitely agree with that. A lot of machine learning engineering roles don't require a higher education. So personally, my plan was I would try my very best to get into like a role that I would like either a data science or machine learning engineering role for full time before I graduate, basically, or as I'm graduating. Like either I'd get the experience through my co-ops or like whatnot. And if I could make it before or when I graduate, then I guess that's good. And if not, then I would pursue like a master's degree. So that's the common track that I've seen with a lot of data science students, because like no one want like people don't want a lot of people don't want to do a master's unless they need to, unless they see the necessity of it. So I would say if you have research experience like doing a URA and you had a few data science / machine learning co-ops, hopefully you could get into the field, you could break into the field as an undergrad. But if not, a master's is definitely a viable option. And a lot of universities offer like accelerated masters that are only 1 year. So it's often it's not even too bad to just do a master's then.
I agree with everything like I guess Sid and Hillary have said. I just want to add one thing is even if you can, so yeah, I totally agree in that if you want to do research, you definitely should do an advanced degree. If you don't want to do research, it's definitely not necessary. But I kind of want to talk a little bit more about the research side as well. It is possible to get roles in research without like a master's or PhD. So for example, like a research engineering role within various companies. But I will say that without a PhD or master's, you have a lot less independence in your research and you're doing more engineering work. So if your goal is to lead a research idea, establish your own ideas and really do research, it's like difficult to do that either without a couple years of experience or without a PhD master's. And so even though these roles are available, like if you want to do research, like you really, really want that advanced degree for sure, especially for the independence.
I'd like to add that like machine learning research masters are actually, very well funded because, business people, they hear the words machine learning, AI, and they're like throwing money at you. So like basically like you don't pay any tuition. You just need to pay for your rent. And like if you do research, if you do like an applied master's, then you have to pay tuition. And also, I highly recommend doing your master's in Canada, actually, because if you do in the US, like if you do a master's in the US, it's basically like a money grab. Like I actually got into some US programs, but it would cost me 100 grand USD for that master's program. Whereas in Canada, I'm actually getting like paid like grants and stuff. And like we have great like schools as well, like U of T and McGill, where Bengio is as well. UBC is not bad, and etc. Right? But I'd say that if you're a genius and you want to go for that PhD, like direct PhD at the US, then that is fully funded for research. But I want to warn people that like schools like Berkeley and Stanford and whatnot are highly competitive. Like everyone in the world wants to get into these schools and they have limited spots for international students. And so even if you're a genius, I know people with perfect GPAs and publications and best paper awards and they were rejected. So yeah, that's just like a warning for PhD in the US, yeah. So don't be discouraged.
Okay. So I guess we're at 7 p.m. right now, and that was all the questions I planned for tonight. So I'm going to open the floor up for questions. So if anyone has questions, feel free to just unmute yourself or ask in the chat.
I have a question. Can I go ahead?
Yeah, go ahead.
Yep. My question is specifically to Hillary because she is not from a computer science and that background. I'm a mathematics student as well, and I want to break into the field of data science and machine learning. And I usually have this question that generally people with a CS background have more knowledge in programming and uh, the more technical knowledge. And sometimes it can be hard for you to break into the field without technical knowledge. So how did you achieve that technical knowledge by breaking into the field?
Honestly, it was not easy. I always got asked the question in interviews, like every interview was like, so you're in biomedical engineering. I thought you were an interesting candidate. Why did you want to do like the software development role or data science, right? And honestly, like at 18, you don't really know what you want to do. Like there's like, how can you tell an 18 year old to make a decision about what they want to do for the rest of their life, right? Eventually you change your mind. And I highly believe that even without the degree of like computer science, like you can learn, I think that like, it doesn't change the fact that I'm passionate about machine learning and that I'm good at it, if that makes sense. Like it just required a lot of extra effort. Engineering by itself is already like 40 hours of class a week. Like it's a lot. And then on top of that, I had to learn machine learning, but yeah, like I couldn't have done it if I wasn't passionate about it, to be honest, because with machine learning or like things that I enjoy in general, I hit the state of flow, which is basically like you're in like super concentration mode. And so like for me, it's easy to study because I enjoy it. Whereas like engineering was really boring for me, to be honest. But I'd say like, don't be discouraged. If it's difficult to switch programs, just keep going for what you really enjoy. So if you really love data science, then learn about it in your free time, do side projects, reach out to professors for your A's. You have to take a lot of action if you're not studying this in your undergrad, I would say. And it is a lot harder, but eventually you will make it. Yeah.
Thank you so much.
Just to add on to that.
No, go
Sorry,
ahead.
go ahead.
No, go ahead.
Okay. I was gonna say like if you're a math student, I definitely wouldn't say you're at any type of like disadvantage for entering the data science field. Like a lot of my friends like who are majoring in statistics are actually doing like data science co-op roles because like people enter data science from like many different directions. Like CS is just one of the routes, like from the software side. A lot of people purely study statistics and then they move to like data science roles through that. So like definitely don't think there's like you're at any disadvantage. Like a lot of the CS students, for example, would have to spend a lot of time learning the statistics or like some like take higher level math courses that are not part of the degree to like benefit or to like break into the field. But for you, you would have to like take some of those CS courses on the side, like as many as you can, or learn it outside of university. So it's definitely not a disadvantage. It's just about like how much effort you want to put into to get into the field.
And I also want to add, just because you're a CS student or a math student, data science, whatever, is not an excuse not to take the initiative as well. Like by the time you learn these things through coursework, you're going to basically be graduated. Like I'll give you an example. For me, this term, I'm taking my first real machine learning course. And this is like 3 URAs and 4 machine learning co-ops later, right? Like you got to take the initiative to learn these things on your own if you really want to experience different things in the field, as opposed to having one co-op left after you take your first machine learning course. So yeah.
And
Yeah, just to, oh, sorry.
go ahead.
Just to add up, like it's totally true that like they're really like not just looking at CS students, like they're definitely looking at a lot of math students and stat background because that's really important. Like some people even say that machine learning is pretty much just stat. It's not completely true, but like it's really relevant. but also just like if you wanted to gain like programming knowledge and try to pick up like some languages to learn about, and like especially in machine learning, this field, like Python is really helpful.
Okay, so we have a question from Arun. How would you approach getting a URA and or doing research in general if you're not sure about what you're interested in? So this is the first part, and I think the second part is directed to Nicholas on any suggestion on quant interview books.
I guess I could go for, I could start with this one. When I was applying for my URA, so for some context, I started my URA in May 2019, and I would be ending it in April 20. So what am I saying? In May 2020, and I'm ending it in April 2021. So it's 1 year essentially. When I was applying, and this was back in February, it was essentially a Google search, professors in the faculty of mathematics, going into the directory for statistics and the directory for computer science, and then literally going professor by professor. Is this remotely related to what I'm interested in the sense that there are professors that are working in like data cleaning procedures. I think there's like multiple projects in the CS department that talk about like optimizing data wrangling and cleaning. Is that something I would love to do? Sure, just send in an application. Some of them have like web forms. For others, I just customize like a very brief email template, maybe like 100 words, 200 words, and just send my resume across. And here the play was numbers, mainly because there isn't a very formal application procedure. So just keeping your egg in like just having like 5 emails sent out, not very ideal. So I think I sent around like 25 maybe for the URA position in Feb. And yeah, so it was fairly broad. It was everything from say from I think there was a research project on like optimizing visualizations, like data visualization techniques, to my current position, which is like working with like heavy tail distributions, like risk management of sorts, to like data cleaning. There were like computer vision projects. It was fairly broad. So I wasn't sure which of these I would really be interested to research in. So I was fairly broad in what I applied to. And yeah, I mean, I'd leave the quant stuff to Nicholas, but there's actually just one book that I really, really recommend. It's called Advances in Financial Machine Learning. It's by Marco Lopez de Prado. It's by far like the best read that I've had, and it specifically talks about like machine learning being applied to like financial data sets and like time series processing. So it's amazing. But yeah, go for it.
Yeah, I totally agree with Navya said. It's like also the key word that like the most important word he said as an entire talk was like remotely interesting, because yeah, for your first URA, you're going to be like applying. I think, yeah, I applied to almost 15 or 20 different, like emailed many different props, and like very few got back because your first one, you don't have much experience. And so, yeah, definitely like just go through the directory. Anything that looks kind of interesting, you should go for it, because for your first one, you don't have much experience. And then for your later ones, you could be more picky. My URAs have been shorter, just 4 months in length each, not a year long. So that's a difference. And in terms of what skills you offer, like if you are even a math major, like an actuarial science major, computer science major, whatever, you have certain skills, whether it's like data analysis, whether it's like software development. And these are all important things for like research labs, especially machine learning research labs. And so props, if they take you, they definitely have some tasks for you to do. Typically your first one, you may not be doing real research in quotations, but definitely after your first couple of months of experience, like you'll be doing more real research or kind of getting onboarded. The quant book I was going to recommend, it's called A Practical Guide to Quantitative Finance Interviews. I can also like add this to the things we're going to send after the event. But it's basically like a bunch of brain teasers and probability questions, which I found are super relevant to the actual questions I've been getting. Quant interviews, at least, so I want to emphasize I'm doing very poorly at them, but at least the ones that I've had so far, they don't assume any financial knowledge. They're very much interested in how you think, and they're willing to teach you how to do the actual finance part once you get there. These quantitative trading firms and these high frequency firms, whatever it may be, are a lot more interested in finding people who have high potential and high mathematical ability and intuition, and then training them to be good at finance. So at least that's what I've learned so far. Again, maybe Hillary should say something about this because she's done quant, but I have this is just my experience from like interviewing this term.
No, I agree with everything you said. Yeah.
I was actually wondering if Sabrina has anything to add on the quant part.
I guess it's definitely true that the interviews are pretty like math heavy, and it's not really like programming related, even though like it is required that you know programming, like and also it's just like very probability heavy, very statistic heavy, and very math heavy. And yeah, that's pretty much like you just really have to have like a solid math background and foundation.
Okay, so I'm gonna wait for around 10 more seconds to see if there's any other questions. And if there's nothing else, I think that's gonna be a wrap up for tonight.
Hey, I have a question about actually working. So I'm currently working this term, and I've been working on this one classification problem for a month, and all the classifiers I've learned in school failed horribly. And it's making me question like if I actually learned anything from school, because all of them, like naive Bayes, logistic, SVM, random forest, XGBoost, they really, in theory, they should have worked, but I think because our data is really kind of sparse right now, and we had to do quite a bit of imputation, all of them, like I think the best result we got was like a 60-70% accuracy. So I'm working in a startup right now, and my lead, the data science lead on my team, doesn't really have he's a wonderful lead, but I got the sense that he doesn't really have much experience either, because whenever I propose an idea, he's very quick to say, oh, just implement it and try it out. And I'll spend like 3 days implementing it. And like, it's like every time we just fail. And like, none of us knows what's going on. Like we can't really put our finger on why it fails either. Do you guys have like any suggestions in terms of just like getting directions? Does this happen often, first of all, like at work? And to feel like there's this like large gap between what you learn in school, what works in theory, and what actually works in practice. And also, do you have any suggestions in terms of, is it okay if I talk to people, because there are other people on my team who isn't working on the project that I haven't really talked to, in terms of like seeking help in solving the problem?
Yeah, this is, at least in my experience, this is like super common. I mean, well, if it was easy, it would have been done in like half an hour, right? It's like, this is a super common occurrence. And I think there are a couple of things to keep in mind. The first one is it's always a data problem, not a modeling problem. Like you've always got to think about where the data comes from, why, you really have to be focusing on feature engineering, understanding data sources, understanding cleaning data. And that's like, modeling is like, if you look at the state-of-the-art modeling in terms of Kaggle, for example, it's all just, like a, what's the word? It's like the the sink method. I don't know what it's called, but you try a bunch of methods and see what works. And so it's always a data issue. Sorry?
Ensemble?
No. This is like the kitchen sink method where you throw everything in or something.
Oh yeah, a lot of
yeah, exactly. It's always that. So it's always a data issue. And the other thing I would say is like, at least from what I've learned in my co-ops, is if, first of all, you don't have access to more data, you can't pay for more data, you can't collect more data, you have tried all your models exhaustively, and you have used up all the resources of expertise within your company, it's always a matter of reframing the problem to see if there's a different way you can approach it. Like, so I'll give you a very specific example. In my first co-op where I'm doing fraud detection, we had very, very few labels for actually identifying fraud. So any model that we trained was going to be trained on a tiny amount of data, a very biased set of data, because this is like fraudulent cases that were caught before, right? We're trying to catch new fraudulent cases. So a very biased set of data, very sparse from different sources, different collection years. This was collected over the 20 years, and the methods have changed like every 5 years. It's ridiculous. And so obviously models were not going to perform well in this situation. And so really the goal of our data science team was, how can we think about this problem differently so we can like model it differently, and so we can solve our problem in a different way. So concretely, like my project, I wasn't predicting fraud directly. Instead, I was building a model to predict. So I was working in long-term care insurance. And instead of predicting whether a case was fraudulent, we did it in an unsupervised way where we predicted how much someone should be charging us given the data we have about them. And then we would analyze outlier cases for fraudulent activity. So obviously this isn't perfect, right? Like we're not identifying fraud directly, but we're identifying proxies and we reframed the problem. And so our data fit the problem. And so I hope my little rant there gave you maybe some insight about how at least I've dealt with it and things that I've seen.
Those are nice. Thank you.
I'll just add something here, that the fact that there is a fundamental baseline in noise that might vary from one data set to another, in that a lot of features might be very close or more or less the same, while your prediction labels might differ. So in some data sets, that baseline might just be, say, a 3% error, which means that you can get close to, say, a 0.96 or 0.97. And some, that base error might be much larger, that error term might be much larger. And so no model can fundamentally cross that threshold. But I mean, I would suggest that there would be a few things that you could try. Maybe, say, run like feature importances on each of your on each input to your model, recognizing whether, obviously any classifier will pick up like multivariate dependencies, but just as an individual feature level, is there enough gain, maybe like entropy or Gini, that particular feature is offering or bringing to the table? Is that, like, if you're plotting the distribution of a feature for like two different labels, is there enough distance between those distributions? And that is essentially comes back to the data problem that Nicholas was talking about. Like, fundamentally, can these labels be predicted from the data that we have? And it also comes down to a lot of cleaning procedures, right? Like when you're imputing data, maybe some data should not be imputed because the fact that there is a missing value might be a proxy for something else that's going on. Or, say, imputing with your mean might mean that any tree-based method will, say, pick that as like a division for like a particular node, which may not be the results that you're looking for. Or, I mean, yeah, or if all values that are usually, say, 15 or 20 are being imputed with like a 0 when they're missing, maybe that really affects, say, the weights that are assigned to them when, like, you're dealing with, like, say, a neural network or something like that. So being very careful with what you impute it with. And just maybe if it's like an imbalance problem, you might want to look at, like, say, a different kind of loss metric. Say, if I have like a 5-to-1 imbalance and your data in your label is fairly hard to predict, you might converge to like a local minimum, which is just like predicting everything to be 0, like just a dummy that, well, has a good loss metric. So maybe you want to try something that's imbalanced, maybe something that decays over time. Maybe some of that might be relevant. But one thing that I would really recommend is just say using feature importance library, something, say, like a SHAP, or say inbuilt tree methods, to see whether any of your input features are actually relevant in getting that 70% accuracy that you currently have. It may be possible that that 70% is mainly being driven by, say, 3 of the 25 features you're giving it. So maybe there are different kind of features that you should be focusing on, anything like that. But yeah, that's just my 2 cents.
I think like we don't have enough context to kind of tell you exactly what's wrong, to be honest. But another tip I'd like to add on is potentially like looking at your predicted output and the actual output, and just even inspecting the data like manually can give you a lot of insight. For example, like I had like some sort of sentiment text classification model that I had. And I was wondering, like, why is this model getting 30% using like a state-of-the-art model, right? And then I inspected the data, like just manually, and I realized that my data had a lot of junk in it, like a lot of things that just did not make sense, like sentences that did not make sense and did not correctly answer the question. And so that essentially the data was like super noisy. So yeah.
I just want to answer your the second part of your question about talking to coworkers. Like you said, there's a few people on your team who you haven't gone to. Um, as a co-op, I definitely would not be afraid to ask people outside of your direct team or outside other than your direct manager, because as a co-op, you definitely have the opportunity to talk to a variety of people without getting judged. So I wouldn't be afraid. I wouldn't be afraid to go out and gather as much knowledge as you can. There's definitely someone there who will be able to guide you in some direction that might help you solve the problem. And especially because your co-op is only 4 or 8 months, you don't want to spend more time than necessary solving a problem. Granted, a lot of these data science problems do take months to solve sometimes, and that's totally okay. Like sometimes it's just constant tweaking and updating to and like uh like little things like that that could that'll lead to your solution. But yeah, definitely don't be afraid to ask other people at the company.
Sorry, I just want to add one more thing. I know I'm talking a lot, but just last thing. I guess for like a data science problem at a company, it's like there's like kind of two more important things. The first one is like, what is an acceptable level of accuracy or like loss? Because it's not like Kaggle, right? You're not going to get perfect, and most likely you're going to get very far from perfect. Like even when you said 70%, I was like, wow, 70% sounds great to me. You know, like when in practice, like sometimes that is great, right? So you got to first establish that threshold. And then once you cross it, you stop, because there's no point spending, you know, company's money just fine tuning for months, right? You kind of got to go for a threshold, be like, okay, for our product, for our purpose, this is enough. And we can improve it later once we address more important things. The next thing I want to say is, you know, again, like real life is sometimes not like Kaggle and not like other projects that you may do. In practice, in my experience, so I don't know if this is true in real life forever. Obviously, I'm still a student, but I basically have a standard script where I try a GBM and a random forest, and I do a hyperparameter search, and then I get like an accuracy, and that's my baseline. And then from there, it's not a matter of trying new models. It's a matter of understanding the data better, because honestly, like anything over for non-deep learning problems on like structured data problems, a GBM and random forest are really going to give you good results after a hyperparameter tune. So after you have some baseline, it's really a data tuning problem. Understand where it comes from, understanding what you can do with the data, understanding how you can think of the problem differently. So I think in practice, the modeling side and implementing models should be a very small amount of time. And most of your time should be like data processing, thinking about your data and thinking about your problem.
I have another question. So I'm actually currently working full-time, not as a co-op. I don't know if that changes the situation in terms of asking for help from people on our team who are working on different projects. And another question that I have is, this is Hillary can probably answer this, because I noticed your supervisor is actually Frank in Vector. He's actually working my company right now, and I want to kind of do a part-time URA type of thing with him, and I haven't had the courage to ask him yet. I'm not sure if it's like appropriate for me to ask, since I'm working there full-time and I'm not really on his team. But I'm definitely like really interested in NLP and a lot of the projects he's worked on in the past. And Frank is just in general a very busy man. I don't think I've ever caught like even 5 minutes with him. And I don't know if this is something that I should discuss with my manager first. If I want to do like on the side, on the weekend, in my free time, do like a URA thing with another employee in the company, if this is allowed, or what are your thoughts on that?
So you're working at Surgical Safety, right? His startup? Or is this, okay. Anyways, that doesn't matter. But I think that for sure ask your manager to see if you can do research outside of the company, because it's kind of a tricky situation when you're working in a company and doing research at the same time, because they might want to own the rights to your research, right? So you just need to run that through your manager first. And then after that, if you're interested in Frank's research, I assume you're interested in NLP in medicine, right? So I would just, what I did basically was I went for it. I just emailed him. I was like, hey, I saw that our research interests are very aligned. I'm also interested in NLP and healthcare. And I sent him like a copy of my transcript, my resume, and then also like a side project that I did or a project for school that I did. That was very related to his research. So it was just like mental illness detection from text. And it used like a bunch of like state-of-the-art NLP models. Like try to just, yeah, I would just like send him an email telling him that you'd like to meet to see if your research interests align and if he would like to work with you. And be sure to mention that you work in the same company because it shows that you guys are connected in some way. And in your email, I would make sure to sort of emphasize that you're really interested in the same things that he's interested in. So I would go on his website, read some of his publications, read like his research interests, and sort of cater your email to sort of his research. Yeah. And make sure your resume reflects that too. Yeah. But yeah, he's a very busy man. Even when I have my one-on-ones with him, I don't even want to ask him how his day is because I'm wasting time. That's how busy he is. Yeah.
Like with other people, he's always working while he's eating. It's like impossible to chat with him.
Yeah, I don't know how he manages it. He's also a father of 2 children, has 2 startups, and also a professor of like 15 students. It's crazy.
I feel like that's a lot of props at Vector. They just like are doing so much at once. It's so ridiculous. I don't know how they have enough time in the day.
I think they're geniuses and I think they don't sleep much because Frank would Slack message me at 6 a.m. and also at like 12 a.m. So I don't think he sleeps much. So
yeah, I guess that's it for tonight. I guess Trista, if you want to connect with Hillary afterwards, and then also we're waiting for so after Nicola send that list, maybe you can send that in Discord on the resources channel, so everyone can see it, and we'll really appreciate it. And thank you all for your time.
thank you for hosting, Melody. I actually learned a lot from the other speakers as well. So I really enjoyed it.
Melody. It was a great experience.
Yeah, thanks
Yeah.
for
Thank you so
hosting
much.
it.
Yeah, thanks so much for hosting.
Thank you for being here. Good night.